when you have SAS or SSS, and those two start with S, don't they? Different from the law of sines when they all start with A, if you look at it backwards for the one. Okay? So if you have these two situations with the angle in between the two sides or the three sides, then you use the law of cosines to help you solve it. Okay? This is when you don't have a right triangle. So that's what we're going to practice today. So let's come down here. Solve triangle ABC with side A, side B, and angle C. And you may say, well, how do I know? Well, if you don't know, then draw yourself a little picture. I did. Kind of helps. Okay? So I'm going to say that's 22. I mean, I might be a little off scale, but that's all right. That's 22. This is A. This is B. That means C is down here, right? Where's angle C then? In between them, isn't it? So that's 108 degrees right here. That's angle C. So I know I have, what? SAS, correct? So you need to be able to recognize which one you have to figure out which law to use. Cool? All right, I have SAS. So I'm going to use law of cosines. So look up here. We've got three different situations. In this triangle, we have angle C, correct? And I need to find side C. So here, you're working with angle A. Here, you're working with angle B. Here, you're working with angle C. Correct? So I'm going to have to use this one right here. I don't want to find C. So I'm going to write C squared equals A squared plus B squared minus 2AB times the cosine of C. And then I just plug in what I know. So I don't know C. And A is 22 squared plus 15 squared minus 2 times 22 times 15 times the cosine of 108 degrees. And then you got a big old thing that you just plug on the calculator. And you get C squared equals 912.9512, blah, 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 blah. Keeps going like that. But do I want C squared? No, I want C, so what do I do? You take the square root of both sides, correct? That's how you undo squaring. So C is approximately 30.2. That's little c. So I forgot to write up here what I'm looking for. I need angle A, I need angle B, and I need side C. And I already have side C. It's 30.2. Okay, now, once I have that third side, I could use one of these to find B or A, or I can now use law of sines, which I think is a little easier, because I have this angle and this side, so I can set up a ratio. I think it's a little easier than using that big thing. It's up to you. So now I have to find angle A or angle B. It doesn't matter. I'll set up the I'll look for A here. The sine of A over side A, which is 22, equals, and I'm going to use the C ratio here, the sine of 108 over 30.2. And that's going to help me find angle A. So when I cross multiply all this stuff, I get the sine of A equals 0.69282, blah, 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 all this stuff. But I want to find the angle. So what do I use on my calculator to find the angle? Inverse. So it's going to look like this, the sine inverse of 0.692822, however far you go with your decimals. And that's going to give you about 43.9 degrees. Again, if your ratio creates a decimal that's bigger than 1, what does that mean? It doesn't work. You can't have a ratio value bigger than 1 for sine. There is no set of sides that will give you that in any triangle. So you got to kind of keep that in mind. All right, so A is 43.9 degrees. Can I get B with very little effort now? What do I do? 180 minus 108 minus 43.9 is about 28.1. What do you think? Doable? Okay. So again, that's when you have side angle side or the three sides. Then you just jump in and we're going to try one now where we have the three sides, and you'll see where that's a little bit different, but not bad. Let's turn it over. All right. I have side, side, side. So I need angle A, angle B, and angle C. So if you look at your formula sheet here, it doesn't really matter which one you pick. It doesn't make a difference. I'm just going to do A. I'm going to find angle A first. So let's write that down. The equation. A squared equals B squared plus C squared minus 2BC times the cosine of A. We're going to end up solving for the cosine of A. So let's plug in what we know. 19 squared equals 26 squared plus 31 squared minus 2 times B, which is 26, times 31 times the cosine of A. That's a whole lot of stuff going on. So this is kind of what it looks like when I start to simplify. I put these two together, and that equals 1637 minus, and then I multiplied that together, and that's 1612 times the cosine of A. Now what? How do I start solving this? It's just an algebra equation. This is my unknown. What do I do? Yeah, I got to get cosine A by itself. So I'm going to subtract 1637 from both sides, and I get negative 1276 equals negative 1612 times the cosine of A. Divide by negative 1612, and you get 0.7915, which equals the cosine of A. So the ratio equals this number. I need the angle. What do I do? Put an inverse on your calculator. Is approximately 37.7 degrees. Sweet. So I've got A, about 37.7 degrees. You could do law of sines now. Yeah, it's a little easier. Okay? Because you have a side and an angle, so you can set up at the A ratio for law of sines if you want. Okay, or you can use another one of these equations, but I'm just going to do law of sines. So I'm going to use the A ratio here. The sine of 37.7 over the side A. That's the A ratio. It doesn't matter. Let's just do B. The sine of B over 26. When you cross multiply all that stuff, you get the sine of B is equal to 0.8368. My ratio is not bigger than 1, so I can find the angle. And it would be approximately 56.8 degrees. Is that what you guys got? Hopefully. Okay, and then how do I get C? Easy way. How do I get C? Just subtract, right? Just put it in the basket right there. That's fine. Thank you. All right. And when I do that, I get 85.5 degrees. Okie dokie? You like this better than working with a unit circle? Yeah. All right. Let's draw a little picture. The lengths of the sides of a triangular plot of land are 120, 150, 175. They're giving me SSS. There's a sign to you that you have to use the law of cosines for this problem. So I drew a little picture. Again, it may not be to scale, but 120, 150, and 175. Find the largest angle of the triangle. So I just made that C, doesn't really matter, and this A and this B. And I just labeled it like this. You can label it however you want. Just as long as you're labeling it so you can plug it into the equation correctly. Okay? So I need to find the largest angle. Well, which angle would that be according to the way I labeled it? C. So I'm going to use the equation that has cosine C in it. Okay? So C squared equals A squared plus B squared minus 2AB cosine C. Probably I don't need to work through this all with you. I'll just give you the, after you plug it, well, we'll plug in the numbers just to do it. It's easiest if you put these together. Okay, so it's 30,625 equals 36,900, and then you put all this together, minus 36,000 times the cosine of C. And you're going to get this ratio. Once I do all the algebra, I get this, which is a number less than 1, so I can find the angle using inverse. Okay, you put in the inverse of this number right here, cosine inverse, and it gives you C is approximately 80 degrees. So that's the largest angle because it's opposite the biggest side. All right, last thing you got to do is Heron's area formula. Find the area of a triangle with the side lengths of A, B, and C. It's not bad. This is the formula right here, but you always have to find S first. If you don't have S, you got to find that first, because then you got to plug that number into this formula right here. So you have to find this first. The variable S is called the semi-perimeter or half perimeter of the triangle. Whatever that means. What is a semi-perimeter? Interesting. I didn't look into that. That's interesting. All right, find the area and traffic of the traffic triangle with sides 750, 410, and 620. So again, I like to draw pictures. I can't help it. 410, 750. It probably doesn't really make a difference. I probably don't need to do this, but it helps me because then I label my sides A, B, C. And then I know what numbers to put into the formula. So I'm going to say that's A, that's B, and that's C. It doesn't matter what you make it. All right? So I always have to find S first. S is equal to 1/2 A plus B plus C. Well, that's easy enough. S is equal to 890. This is my A, B, C. Now I'm ready to use the area formula once I found the S, the semi-perimeter. It's bugging me that I can't tell you what that means exactly. I'll find out. So then I go back to the area formula, plug in S where needed, and A, B, and C where needed. I think probably the most common thing with this would be forgetting to take the square root at the end, just like the distance formula. Do you remember the distance formula, you guys? No. It's from geometry. That's a big in there. 890 minus 410. A lot of, so do everything underneath here first, and then take the square root. And then it's approximately 127,075 feet squared for the area of that traffic triangle. See if you got that. And then this is what I want you to do for practice. It's not much. 892, 9 through 33, every other odd, and 44.